Okay, so I would like to discuss the finer points of differentiability, which is basically 14.8 in your book. And the idea is that I probably lied to you a little bit the other day. So if we have some function of two variables, right? What does it mean for this thing to be differentiable? Okay, is continuity enough to be differentiable everywhere? To be differentiable somewhere? How about, let's, maybe in one dimension, right? So how about this thing? Yeah, so you might remember that this is the absolute value function, right? Which in one dimension is continuous and not differentiable. So how would I make an analog of a continuous, not differentiable function in this case?
A cone.
Perfect. Yeah, so continuous is not enough, right? Because I can make some kind of cone. Okay. All right. What if the partials were to exist, for instance? So if I could take both fx and fy, would that be enough?
You also need fx, x, and fyy,
Ah.
also be. Well.
So that would definitely be enough, right? You guys see that? Because if I could take fxx and fyy and fxy, right? That would imply that fx is continuous in both x and y, and fy is continuous in both f and y, or x and y. You guys see that? So that would definitely be enough for all of the partials to exist. Right? If fx, fy, fxx, fyy, and fyx, fxy, right? If this whole list is continuous, then I'm good. You guys see that? That would be enough to apply differentiability. So the thing I want to caution against is things less than this are not quite enough in a lot of cases to get differentiability. Sometimes you can get both partials and they can kind of look fine and things will still break. You guys want an example of that? So something like f of x and y is x to the 1/3, y to the 1/3. This thing doesn't seem like it'll probably have any problems, right? The cube root of a function and a cube root of another function, I multiply them together. This is definitely continuous. It should be pretty happy. Yeah, unfortunately this one has problems with these. Yeah, so it's 0 and x or y is 0, right? And so I'd probably look for problems at 0, 0, right? Yeah, it turns out if you fiddle with this enough, you'll find that these guys are okay. These guys start to get all jacked up. You guys see why? Can we calculate those? Yeah. So let's fx for my funky function example here. Fx is y to the 1/3 x to the -2/3 times 1/3, right? Okay, so what happened? Well, this thing's fine everywhere except 0, right?
Which it has to be okay at 0.
Yeah, and I want it to be okay at 0, and this isn't. You guys see that? Okay, so it's enough if all the derivatives exist and are continuous up to second order. And that's going to happen most of the time, so we're going to call that a day on differentiability.